Hi everyone, in this video I'm going to give you a little bit of extra help on the integration activity. The first thing that'll help you out on is graphing my function y equals the square root of x. What I'm going to do is I'm going to call this guy my y-axis. Maybe I'll darken it a little bit, make it nice and blue. Okay, and then this guy is my x-axis. Make it blue. My scale, I'm going to spread out my scale, spread out your graph on the x-axis. That was my suggestion. If I'm going from 0, which is clearly here, up to 4, I could count every other box as 1, maybe even every third box is 1, but I'll just go with every other. So this is 1, this is 2, this is 3, this is 4. So I'm spreading out my x-axis a little bit. Similarly, my y-axis, if it's the square root of x, the square root of 4 is 2, so I'm definitely going to spread out a little bit here. So let's say that like this is 1 and this is 2. And then the only points that I can plot are 0, 0. Or the only nice points I can plot are 0, 0. The square root of 1 is 1. And then the square root of 4 is 2 right there. Okay? And so there is, I don't like that line. Here is my curve. I don't like that one either. Let me try this one more time. Here is my curve. Y equals the square root of x over the interval from 0 to 4. Okay, and then it says graph it and divide it up into 8 rectangles, as I did in that video. So if I'm going from 0 to 4, I'll draw this line down here. That's my the end of my region, and I want 8 rectangles. Gosh, good thing I skipped every other line. That should make these rectangles easy to add on. Okay, so my first rectangle, starting here, I'll go red now, at 0, is not very tall. And it's kind of up to you. If you've already started this and you chose to use different endpoints than I am, that's okay. So what I mean is, at 0, I could use this height. Ooh, that's a bad line. As the height of my first rectangle. Or I could choose to use this height as the height of my first rectangle. So you're either using left endpoints or right endpoints. Either is fine with me. I'm going to choose this guy as my left endpoint. Okay? And then I'm going to choose this guy as my next left endpoint. And then I'm going to choose this guy as my next left endpoint. And I've got my first 3 added on there. Hopefully you could handle finishing the rest. Okay, so that's the first part. Then in step 2, your number 2, whatever you're going to call it, using your 8 rectangles, approximate the area under the curve. First it says, find delta x, which represents the width of each rectangle. Well, if the region is from 0 up to 4, and I have 8 rectangles there, hopefully you can see how delta x would be equal to, delta x would be equal to a half. Okay, and that half goes in that column, boom, the whole way down, fill it in, 1/2. Okay, and then, so everything else, for those 8 rectangles, you need the, you need the x value. So what is the x value at my first rectangle right there? Since I chose left endpoints, that's an x value of 0. What's the x value at my second rectangle? Since I chose that endpoint, I've moved over a distance of 1/2 or 0.5. For my third rectangle, over there, my next x value is at 1. All right, now what's next? I'm not going to fill in any more. That's up to you to finish. The height at the x value. How am I going to get that? Well, if my equation is y equals the square root of x, and now I have all of my x values here, here, and here, the square root of 0 is 0. The square root of a half is some number. I won't use a number sign. I'll write the word number. Some number in my calculator. The square root of 1 is 1. Again, continue on down. And then I already told you what to fill in the delta x column. And then height times delta x, bust out your calculator again, and do 0 times a half. I think you get 0. Do some number times a half. You get, I don't know. Do 1 times a half. You get a half. Fill in the rest, and then add them up to get your final area. Boom. You have the area under the curve. And then, just a reminder, there's a back. There's a page 2. Well, there's not really a back unless you printed this double-sided. Okay, but make sure you fill in, obviously, the rest of what I haven't. And keep in mind, it does say 3 decimal places in the chart. For the final area, give me 2 decimal places. Round correctly. Then when you flip over to the back, you have to evaluate the definite integral. I'm not going to give you any help with that other than to say if I'm integrating and using my power rule, I'm writing that radical x as x to the 1/2 power. Add and divide when you take the antiderivative. But that's up to you to do that one. Show all of the work. If you just try to figure out how to do that in your calculator, you're not going to get any credit. Show that work. Then for number 4, how close was the approximation? Like if on problem number 2, you get an answer of, I don't know, 15.2. You're not. And then in problem number 3, you got an answer of 16.2. How close are those two numbers? They differ by 1. So really number 4 is just asking you to subtract. How far off were you in your approximation? And then number 5, for bonus, I'm not going to give you help with this one because it's a bonus. Find the percent error. So I'll just say Google the percent error formula and figure out what to do. It's a bonus. Okay, so there is your help video with the activity. Make sure that you get it done by the due date, which I can't remember right now, but it's in Blackboard, and which you're in right now because you clicked on this video from Blackboard. So get it done by the due date, and email me if you have questions beyond this help video. Thanks for listening.